first quarter to do some math with me. So you'll be fine, I promise. We're not doing any more polynomials, so there's that. Okay, yeah, all right. I'm glad you're here. We have kind of a lot of stuff to get through this quarter, and if you were in second quarter, this is sort of relevant to you. The classes are an hour long. So I did a half hour last quarter. This quarter, I'm going to do an hour. That's just going to allow us to do more of our work during class rather than you having to go do it individually. So there's that. Required sessions are Mondays and Thursdays from 1 to 2. You all know how to get here, so that's good. I'm going to just expect that you're here then from here on. We have a couple of tutorials to get through, just some like kind of general stuff for the beginning of the quarter, and then we're going to get into some exponent rules stuff. So there's that. If you have questions, feel free to put them in the chat at any time. I'll try to catch them as they come in. We'll see what I can do with that. Okay. All right. Here are the things that I need to talk about. Most things should be basically the same as what we've done so far. You need to be at the live lessons. And you need to kind of do what you got to do. That's it. It's more or less the same. The lessons are still going to be posted on Classroom as a document. You just click through the links and you go in order, right? So it's more or less the same. What I do have this quarter that's new is Remind. And this is just another way for me to communicate with you because I am trying to find ways that aren't just like you getting bombarded with more emails. And so what you can do is you can send a text message to the number 81010 with this, what looks like a Twitter account or handle, right? At alg2savhs, okay? Send that there, and then you'll be added to my Remind group. This is just gonna be a way of me sending really quick texts to you just to say, hey, we have a meeting. Hey, can I connect with you? Those types of things, okay? So please do that. You have to opt into it. You have to do it yourself. I can't add you to this group. So please do that for yourself. So if you want the link, I'll copy the link into the chat also. So you can do that there. Boom, there it is. Let's have one of those awkward silences where I wait for you to do something. Okay, so there's that link in the chat. That's that. Okay, next thing. I'm just begging you to try your best to stay up to date and like reset the intention that you had for school this year and be like, okay, this quarter, I'm really going to be up to date and I'm really going to make sure that I get things done. I'm pushing you to try to communicate with me as best as you can. That's part of why I'm giving you Remind, because that's another easy way to communicate with me. It just makes it so that like you don't feel weird about sending me a message if you need help with something. So shoot me a text on Remind. You can email me. There are lots of ways to get a hold of me, and you all know those things because you've worked with me before. Okay, your weekly schedule looks like this. I will post new lessons on Mondays, Tuesdays, Thursdays, and Fridays, not on Wednesdays. We have live lessons that are required on Mondays and Thursdays. And then I have sign up only help sessions on Wednesdays and Fridays this quarter. This is a new thing. I'm asking you to sign up so that I know that you're coming. This allows me to make sure that I know who's going to be there and what we're going to work on. But it also helps me because then if I show up and no one's there, then I know that nobody's going to be there. Okay. So just for my own sake, there's a sign up link here, but it's also on the documents. Okay, so it's in the announcements. It's on the very bottom of the document. It tells you how to do it. You just click on this link and it takes you to this sign up sheet. So you can find a slot to meet with me. Okay, so that's what these gray boxes are right here. Okay. Google Classroom is basically the same. It looks like this. Okay, here it is. I post announcements here. Classwork is here. It's the same as it always has been. Nothing new here. For those of you who are in quarter one, this is a new thing. I have a calendar that just tells you what we're going to be doing each day of the whole quarter. This is an approximation right now, but I will be linking things in as we go on this so that you can just kind of get that information. Okay. Yeah. Okay, back to this. Google Calendar, if you would, please. go to calendar.google.com. It looks like this, calendar.google.com. Type that into your browser and it should take you to this. Yours will look different because I have some meetings with other people throughout this, and so I can hide those there. Those are not that important. But what is important is these show up, and these are the thing that you're in right now. So to get this, you need to check the box on the left side. It should be a yellow box that says Algebra 2 Quarter 3. Click that box so that you can see these announcements, okay? That's just something that you can add to your calendar so that you don't have to think about when the live lessons are. You're just going to get notifications when that happens, okay? So try to do that, please. Okay. All right. I showed you the class calendar already. That's the document on the very bottom of the Google Classroom page. It's just an opportunity for you to see what's going on in class each day. That's also where I'm going to post the videos for the live lessons, the recordings of the live lessons. Okay, assignments. Assignments look the same as they always have, okay? There are announcements at the top, learning targets, and then the tasks are in the big pink box, okay? That tells you what you need to do. The assignments are technically due at 8 a.m., but that just means that I need you to try your best to stay on top of your life, okay? So just try to be more or less on top of what's due when it's due. There are no hard deadlines, but I really need you to try to be on top of it. This is just sort of your goal pacing schedule. But if you get behind, if you are one of the people who got behind first or second quarter, you now know how difficult it is to get caught up. And so let's just try to not be that again. Okay, that's that. Okay, grading. This is not new either, but I'm grading on learning targets again this quarter. That just means that you have to show me evidence that you're learning each topic, okay? Those are the 100% category in Skyward. So nothing else affects your grade except for your understanding of these learning targets. So if you can show me mastery of these things, you're gonna get an 8 out of 8 on every learning target. If you're like, that quiz did not show what I know about this topic, then you have to communicate with me. You can send me a reminder, you can send me an email and just say, hey, I wanna work on this learning target, and then we can make a plan to fix your grade, okay? The daily work is checked off in Skyward. So I'll give you a 1 or a 0 if you do the daily work, but it's not going to affect your grade, okay? What affects your grade is the learning targets. What affects your grade? The learning targets. Okay, I don't know what this slide is. Oh, this is just like what the points are, how the point breakdowns work. Okay, this is the same as every other class. Okay, learning target rubrics, I'm also going to post on Google Classroom as we go. I just haven't finished making them all the way yet. So that's why they're not on there yet. Okay, what's happening this semester? These are the 4 things we're going to do. Radicals and roots, that's what we're starting with today. Exponentials and logs, probability and statistics, trigonometric functions. Okay, we're jumping around a lot. We're doing chapters 6, 7, 11, and 13. So that means we're skipping chapter 8. That means we're skipping chapter 10 and chapter 12. I just don't like even numbers that much. Okay, these topics are mostly unrelated with each other. They just are 4 different things you got to know about Algebra 2. That's all it is. Okay, so here's the learning target for today. And this is where I'm going to start talking about math. And I'm going to try to talk for like maybe 10 more minutes. And then I'm going to put you in breakout rooms to do an assignment together. So just be prepared for that. Okay, today we are working with exponent and radical properties to evaluate and simplify expressions with radicals in them. We're focused only on exponent properties today because you need to know how exponents work with each other, with variables, with numbers, to be able to do any of the stuff that's in this unit. So this is sort of a preparatory day. This is where I'm going to switch over to my iPad, and that means that I need to do like 2 things really quick that I forgot to do. Sorry. Home body. I'm almost there. There we go. Stay with me. Okay, here we go. Exponent rules are not the most exciting thing in the world, and I recognize that. So that's why I'm going to try to do them quickly. Okay, this to the fifth right here says I write my 3 squared 5 times next to each other. 3 squared times 3 squared times 3 squared times 3 squared times 3 squared. Yes, right. Okay, but check out what each of these 3 squareds say. This is 3 times 3, and this is 3 times 3, and this is 3 times 3, and this is 3 times 3, 3 times 3. How many 3s do I have there? I have 10. So that's 3 to the 10th. So if you have a power to a power, a 3 to the 2 to the 5, you multiply the exponents. Okay, that's the only piece of evidence that I'm going to give you that that property works. You're going to have to trust me. Powers to powers, you multiply the exponents. Next. Okay, these two have the same base. They both are 3 to the something. If we expand this out, we write this 3 squared as 3 times 3. And this 3 to the 4th is 3 times 3 times 3 times 3. How many of them do we have? That is 3 to the 6th. So there's 6 of them. So if you have the same base, and you multiply those two together, you add the exponents, a to the m plus n. Okay. This is my evidence that that works. Okay. So what you're noticing already is I'm starting to just write them out by expanding everything out and then counting them up. Okay. So I would recommend that as a strategy for you. Expand everything out and then kind of cross off or consolidate back together. Okay, 2 to the 8 over 2 to the 5th. Okay, this is 2 times 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 2. Did I do that right? Yeah, okay. Like that. That's 2 to the 8th. And it, oh man. And then 2 to the 5th is 2 times 2 times 2 times 2 times 2. Okay, but here's the thing. Each of these is 1. So now I have 1 times 1 times 1 times 1 times 2 times 2 times 2. Okay. Well, all these ones add to 1, or multiply to 1, excuse me. So what do I get? I just end up with 2 to the 3rd. If you have the same base and you're dividing them, this gives you a to the m minus n. Next. This one is just a definition, okay? So if you see a negative exponent, you can take it and put it on the bottom of a fraction with a positive exponent instead. So just the same as this, we could say a to the negative 4 is equal to 1 over a to the 4th. If we go a little bit further with what this means, we can say 1 over a to the negative 3rd is equal to a to the 3rd. I know that's a little bit of a jump, but that's just sort of how you work with fractions and what's going on with the fractions that I'm not going to spend time going through because I think that you're going to remember these and I think you're going to be okay. But this is this. This is the property right here. Next. Okay, 3 to the 3rd is, I'm just thinking about like what is actually the answer? What's the value of 3 to the 3rd? It's 27. 3 to the 2 is 9. 3 to the 1 is 3. The pattern here, oh, look, this is like a geometric sequence. Look at that. Times 1/3. Times 1/3. So 3 to the 0 must be 1. This is the thing that I need to focus on right here, is that 3 to the 0 is 1. And truly, anything to the 0 is 1. This one we already talked about, so I'm going to skip that. Don't worry about this. We already did that one. This is true. A to the 0 is 1 as long as A isn't 0. Because if 0 was, what's 0 to the 0? Nobody knows what 0 to the 0 is. As long as A is not 0, anything to the 0 is 1. Okay. My suggestion to you is that you memorize these 2 rules. The rest of them you can expand and then simplify out. Exciting, right? I know. Okay, one example problem of what we're going to be doing today, and I know that I just made a huge jump from where we were at just a second ago to where we're going. So I realize that there's a big jump here, but I want to show you some of the things that we can do with these exponent rules. Let's start with just the numerator. This 3 can go here and can go here. So now we have x to the negative 12, because that's a power to a power, and a y to the 1 to the 3, which is a y to the 3, because it's a power to a power, so you can multiply those. We're left with, over here, we have x, and then y to the negative 2, and then z. Lots of stuff, I realize that. Let's look at the bottom. Maybe let's just leave the bottom for a second. Like that. Okay, good. Where do we go from here? Let's combine some terms here. So let's look at just the x's on the top. We have an x to the negative 12 and an x to the 1. Those are the same bases. You can add the exponents. So negative 12 plus 1 is negative 11. So now we have x to the negative 11. These two have the same base. They both have a y. So you can add the exponents. So then you can rewrite this as y to the 1, because 3 times 3 plus negative 2 is 1. We just have a z to the 1 up here. So then that's like that. That's the top. What's the bottom? Let's combine the x's. Let's look at just the x's. X to the 3rd, x to the negative 1. Those add to x squared. Let's look at the y's. Y to the 4th, y to the negative 1. Those add to y to the 3rd. And then we have a z to the negative 5th. Now, I don't like those negative exponents because those feel weird. So anytime I see a negative exponent, I'm going to change which side it's on the fraction. So if it's in the numerator, it goes to the denominator and becomes positive. If it goes from the denominator to the numerator, it becomes positive also. So this gives me the only positive exponents in the top. I have y to the 1 and z. And then I'm going to move this down here. So I get x to the 11th. So then x to the squared, and then y cubed, and then, oh, look, another negative exponent. So you can move this back up and write this as z to the 5th. Okay, so that's that property of taking the negative exponents and moving it to the other side of the fraction. Okay, this is almost done now. These two have the same base, so you can add the exponents. So this gives you, on the bottom, x to the 13th. We have y cubed down here also. This part is a z to the 6th. And I still have that y. The only part I need to deal with now is that there's a y and a y here. And I have a y to the 1 and a y to the 3. And so I can subtract those exponents. So I can rewrite this as y to the negative 2, z to the 6th, x to the 13th in the bottom. But now I have another negative exponent, and so that one needs to go back to the bottom for the cost of the negative. So this becomes z to the 6th, x to the 13th times y squared in the bottom. This is my fully simplified end of the problem answer. Look at all those steps. Yeah, it does matter if you put that y to the negative 2 on the bottom. So remember the property that says y to the negative m is equal to 1 over y to the m. And remember the property that says a to the m over a to the n equals a to the m minus n. This is like over 1 right here. So that's why I subtracted it and put it on the top right here. Then I took it and applied this property and put it on the bottom. Okay, lots of stuff there, I realize. I get that. Just one thing, these are not the same. This is 3x squared. This is 3 squared x squared, which is 9 squared. Whoa, 9x squared. Notice this and this are different. Please don't make that mistake. Okay, that's all the like yelling I had to do today. So here's your little summary of the properties for you to know. This is please screenshot this slide thing, because then you can have all the exponent properties we just went through in the last 12 minutes. I'm gonna give you like 10 seconds to do this because I gotta get you in your breakout rooms like ASAP. Okay, moving, here we go. Here's the deal for today. What you're gonna do is I'm gonna send you a link to this puzzle, okay, in the chat. You're gonna click on this link and it should make a copy of a Google slideshow for you, okay? What you're gonna do is you're gonna figure out how these pieces fit together. See what I'm saying? The black print is the original expression. That's the thing you need to simplify. The red print is the part that you need to, that's the answer. Okay, that's the fully simplified version. What you're gonna do is you're gonna go through this and you're gonna like, okay, move this box. If I think that A and I connect, then I might connect them together like this. You see what I'm saying? And so now you can zoom in a little bit and you can be like, oh, this makes sense because now these two are equivalent. I'm not saying they are, they could be, okay? So your job is to figure this out. This is gonna go in a 6x4 box, okay? It all fits together and I have an answer key, so we'll check our work. Okay, in your breakout rooms, one person needs to share your screen because otherwise you're not gonna be able to talk about what you're doing. Try to communicate with each other, make sure that you are talking about the math because this is the only chance that we actually get to work together, okay? Collaborate, you need to organize the puzzle and make sure that it's in the right places. I will be popping in to check on you. Okay, turn your camera on and microphone if your computer can support it and if you're comfortable with it. It's just nice to see faces while you're working. I'm gonna try to get to every breakout room, but I think I'm gonna have like 15 breakout rooms. So I'm gonna try my best. And yeah, okay, make sure you click the button that says ask for help if you need me for something, because otherwise I'm not gonna know that you need help, okay? That's that. All right, so I'm gonna set the timer for like 20 minutes, okay? So this should be plenty of time to figure this out, okay? Then as we come back, we'll check in. If I need to extend the time, we'll do that. And yeah, here we go. Let's open some rooms. Oh, I didn't do it, sorry, hold on. Edit rooms, shuffle, save. There we go. All right, go to your breakout rooms and then let's get going. I know that I only have like a minute and a half left. So I'm gonna try to conclude class quickly here. You and your group should finish that puzzle. I know this is a little bit weird because it's like, well, I don't even know who was in my group. But if you were the one presenting, please share your puzzle with the people that were in your group. Hopefully you remember their names. Okay. If you don't, it's not a big deal. Just message me or something. Finish your puzzle. You can all submit the same puzzle file as your response to the assignment today. Okay. Add my class calendar, set up reminders so that you get the notifications when things are happening. Join my remind. And then the other thing I was going to say is maybe you want to clear out your email inbox so that you can actually like see what happens when something new happens. Okay. Turn in your assignment on Google Classroom. We spent 60 minutes together. The expectation is 90 minutes a day for each class. So set yourself a timer for up to 30 minutes on this, okay? Ideally, you complete it, but I really just want you to spend another 30 minutes on it, okay? So if it's not all the way done, at least you spent 30 minutes on it, okay? All right. That's all I got time for. So stay on if you have specific questions for me. Otherwise, that's all I got. Thanks, everybody.